All right. Hi, welcome back, everyone. So we just finished up a pretty, um, detailed, I guess you could say, discussion about perimeter. And really, perimeter isn't all that complicated. I know most of you know exactly what the perimeter is prior to me even defining it and talking about it. Again, the complicated part about this unit is we're not going to have all the pieces to what we need. And so we have to use previous skills to find pieces, the right pieces. And then, for perimeter, we added them all together. Now we're going to start talking about area. Area has its own set of formulas depending on the shape. And so again, you're going to be missing pieces. We're going to find those pieces with old skill. And then once we find the right pieces, we plug them into some sort of formula. So real quick, let's define area. Area is the two-dimensional space or 2D space inside a figure. Now, one thing to note, area has square units. Now, what square units means is like, let's say everything was in meters, right? Then our answer would contain meters to the second power or meters squared. And raising things to the second power, right? That's two-dimensional, 2D. And then that matches up with the measurement of the 2D space inside a figure. So square units. Now, today, again, only focus is rectangles and triangles. And so the rectangle area formula, you probably already know, it's just simply base times height. Now, that could be your base. Your height can be this side here. Remember, base and height always make a 90-degree angle. It's unimportant to worry about with a rectangle because all four angles are 90 degrees, but that is something crucial. Your base and your height always form a 90-degree angle together. Now, you might not always see that information where I've written it. So bottom and right side, sure, that might be your base and your height. However, you might see the base number on top, the height on the left. And the reason is, remember, the top and the bottom are the same in a rectangle. Left and the right are the same. And so we can place the numbers in different spots. You need to be able to visualize it and put them in the correct areas of the formula. And so base and height can be in various places. I'll keep them on the bottom and right for now. Now, for the triangle, we can talk more about this in the future if you'd like, but the area of a triangle very similar to the area of a rectangle, but it's base times height divided by 2. The reason is, if I made a rectangle which has an area of base times height, right? And if I draw a diagonal in there, now I have 2 triangles. And that triangle fits exactly half of the space that the entire rectangle area is taking up, right? This triangle is half of the rectangle area. And so, again, the formulas are the same, base times height, but since the triangle is half of the rectangle, the area is base times height divided by 2, and that gives you half. Now, real quick, I want to draw 2 pictures in this triangle. Let's start with the one that's just there for you. We're going to consider this a right triangle. And so just like I said before, height and base always have to form a 90-degree angle for each other. We would call this side the height then, and this side the base. And they connect at a 90-degree angle. Now, we don't always have right triangles, and the formula would still be the same even if it's not a right triangle. And so let's say I draw a triangle that looks like this. Where does my height and base come from, right? Well, my base can still be considered the bottom, although you'll see in the future that we can rotate these triangles any way we want. So just like the rectangle, your base might be located in a different spot. But then our height would be if we draw an imaginary line from the tip of that triangle to create a 90-degree angle with the base. That is your height. And so again, the crucial part is your height and your base always form a 90-degree angle with each other. And so look for that, right? Whatever 2 sides are forming a 90-degree angle with each other, those are the 2 numbers we need to use in our base times height divided by 2 formula. And so let's mark that. Height and base form 90-degree angle. And this means they are perpendicular, right? Perpendicular. And so keep that in mind. Now, let's practice, right? And so the first one, not so bad. It's a rectangle, right? So base, we can consider 9. Height, we can consider 3. So area is just going to be 9 times 3. And that equals 27. And those marks mean inches. Remember, square units, so inches squared. Now, in number 2, we actually have exactly what we need here to just plug in these numbers to a formula, but we need to be able to visualize it. And this is not an easy picture to visualize. Now, first of all, the shaded region is your triangle. So we're working with this triangle right here. And so those dotted lines on the outside, those are actually not part of the triangle at all. However, they are lines that help you decide what's the base and what's the height. And the reason is this right here. Remember, base and height always have to form 90-degree angles with each other, but it does not have to happen inside of the triangle. We can draw these dotted, like imaginary lines that still create a perpendicular intersection, and so they're still going to be the numbers that relate to our base and our height. And so our height, I think we should consider 10 because it's going up and down. So then which side is 10 making a 90-degree angle with? It would be 12, the base. So 12 has to be our base. Now, 10 is definitely that up and down side here. Remember, it's still imaginary. 12 is only this part that is dealing with the shaded. And so this imaginary line right there, it doesn't have a number. It's not relevant for the triangle. It simply is there because it's the reason why our height and that base side can form that 90-degree angle, right? And so again, long story short, height and base always form a 90-degree angle. So find the two that are doing that. It can be inside the triangle or outside the triangle. And then we use those numbers. And so our area will be base times height divided by 2. And so that's going to be 12 times 10 divided by 2. 12 times 10 is 120. And then 120 divided by 2 is going to be 60. And again, those are inches and squared. So 60 inches squared. All right. Now, those are relatively nice problems. We didn't have to do a ton of work to get our numbers. They were just already there. But as it happened in the perimeter, we're going to have to work with sine, cosine, tangent, and various other skills to get our bases and our heights and stuff like that. So let's work with a problem where that's happening. Now, this is a triangle. So remember, area is base times height divided by 2. Remember, base and height always form a 90-degree angle with you, and so that's great. We can consider this 8 our base. Then our height has to be this side that I put an X on, again, because height and base make a 90-degree angle with each other. But we need to find the height, right? We don't know what X is. Once we find it, then we can plug it into the formula. And so we see this 22-degree angle here in the corner. That should be an indication to us that we are going to use sine, cosine, tangent. So let's flip colors. Once we identify our angle, we'll identify opposite, which is our X. Hypotenuse is across from the 90, nothing there, so it doesn't matter to us here. So then that makes 8 our adjacent side. So again, SOHCAHTOA, right? SOHCAHTOA. Oop, what is happening? TOA. And we have to work with opposite and adjacent. That's going to tell us to work with TOA. So we're going to use tangent. So the tangent of 22 is going to equal opposite divided by adjacent. So X divided by 8. And then we're going to times both sides by the bottom of the fraction, which is nice because it's a number. Our 8's cancel, leaving us with X all by itself. And so 8 times the tangent of 22 is what we want to type into our calculator. Let's speed this up a little bit. I think you should have a good feel for the calculator by now. And so we'll just jump straight to the answer. That should be 3.2. And so X is going to be 3.2. Now, remember, our X is our height. And so our area is now base times height divided by 2. Base was 8. Height we solved for, 3.2. So 8 times 3.2 divided by 2. 8 times 3.2 is roughly 25.9. We'll have to divide that by 2, and that's going to be 12.9 feet squared. And there's our answer. All right. We'll keep doing this work. Now, recognize in this situation, there's a triangle again. So area equals base times height divided by 2. Base and height form 90-degree angles with each other. So we'll call this one our height since it goes up and down. We'll call down here our base. And they form 90-degree angles with each other. But we don't know any of them, right? We can call our height x then if we want, and our base y, and we have to find both. All we know is the hypotenuse. However, because we know the hypotenuse and this angle, we can work with sine, cosine, tangent, and find x and y. And so across from the 47 is opposite. Across from the 90 is hypotenuse, which leaves x to be adjacent. And we got to find both x and y. So let's start with x. So x is the adjacent. The other number we know is 10. So hypotenuse is the other side we have to work with. Adjacent hypotenuse is the part. So the cosine of 47 is going to equal x divided by 10. Times both sides by 10. And that'll cancel our 10s over here, giving us x. And we just got to type 10 times the cosine of 47 into our calculator. 10 times the cosine of 47 should come out as 6.8. Perfect. But now we got to find y. Only difference with y is we're going to use opposite and hypotenuse. So opposite and hypotenuse is the so part. So that means let's use the sine. And so the sine of 47 is going to equal y over 10. And so this one solves the same way as the other one, times both sides by 10. The 10s cancel in the bottom, and that'll leave us with y. And we just have to type into our calculator 10 times the sine of 47. And when we do that, it'll tell us that y equals 7.3. And now we've got our two numbers, right? The y, our 7.3, that deals with our base. The x, which was 6.8, deals with our height. And so area is going to be base, which is 7.3, times height, which is 6.8, divided by 2. Type all that into your calculator, and you should get 24.9 inches squared. And there we go. All right, awesome. Now, couple word problems. So here we go. Find the perimeter of an isosceles triangle with base 15 and height 8. And so this can be a little bit tricky. We got to find perimeter now. So we want to get all three sides and add them together. Got to know what an isosceles triangle is. So an isosceles triangle has two sides that are the same. Put tick marks through them. Those are called legs. And then our base is different. Our base is 15, and that'll be our bottom. Now it tells us we have our height. An isosceles triangle is not necessarily a right triangle. And so ultimately our height is going to look like this. This is going to be one of those problems where we drop this imaginary line down to the bottom and it creates a right angle, and that line creating a right angle with our base, right, is what our height is. And so our height is 18. Now, in order for us to find the other two sides, we need to know something about what this height in an isosceles triangle does to the base. It cuts this bottom side in half. And so even though the whole side is 15, each little piece of it gets cut in half by that height. So this side is 7.5 and this side is 7.5. And so what that does, if we just kind of highlight this triangle here, right? And so I draw the height, draw this little slit, and one of our slanted sides. The bottom here is 7.5. Our height is 18. That's a right triangle. Let's say we want to find this side. We know two of the sides, so we can use the Pythagorean theorem to solve for x. And we will do that at the beginning of the next video since I am running out of time. Thank you, as always, for your hard work and your patience. Keep it up. You're doing a great, great job.